You use the with statement every time you open a file in Python. But do you actually know what is happening under the hood? I am Mahas. Today, in episode 19, Context Managers, you will learn how it works, how to implement ___, and ___exit__ yourself, how to build context managers with just a generator function, and why this pattern is used everywhere, from file handling to database transactions to threading locks. Let's go. Let's start with the problem the with statement solves. When you open a file, you must close it. If your program crashes between open and close, the file stays open. That is a resource leak. Look at the left card without with. You call open, read, then close. But if an exception happens on the read line, close never runs. The file is leaked. Now look at the right card with. You write with open a file as F, then do your work. When the block exits, for any reason, including exceptions, the file is automatically closed. No explicit close, no leaks, no try finally boilerplate. This is what the with statement gives you. Automatic setup and automatic teardown. The with statement works through a protocol, two special methods. Enter __, and __exit__. When Python hits a with statement, it calls __, enter ___ on the manager. __, is the setup, opens the file, acquires the lock, starts the timer. Whatever __, enter ___ returns becomes the value after the ES keyword. When the with block exits, whether normally or via exception, Python calls __exit__. __exit__ receives three arguments: exception type, exception value, and traceback. If no exception occurred, all three are none. If you return true from __exit__, the exception is suppressed. If you return false or nothing, the exception propagates. The critical guarantee, __exit__, always runs, even if your code inside the block raises an error. That is the entire power of context managers. Let's build a class-based context manager. We create a class called ManagedFile. The __, init__, method stores the path and mode. The __, method opens the file and returns it. This is what you get with the as keyword. The __exit__, method closes the file. Notice, no matter what happens inside the with block, __exit__, runs and the file closes. We return false from __exit__. This means we do not suppress any exceptions. The exception propagates normally after cleanup. Now we use it with ManagedFile of data.txt as F. F is the file object returned by __, When the block ends, __exit__, closes it automatically. Writing a full class for every context manager is verbose. Python gives you a shortcut, the context manager decorator from contextlib. Instead of a class with __, enter __, and __exit__, you write a generator function. Everything before yield is your __, enter __, logic. Yield is the boundary. What you yield becomes the as value. Everything in the finally block is your __exit__, logic. Using try and finally guarantees cleanup runs even on exception, just like __exit__, always running. Look at the code. We import context manager. We decorate ManagedFile with a context manager. We open the file, yield it, then close it and finally. That is it. One function, no class, same guarantee. This is the most common way to write context managers in modern Python. You can nest multiple context managers in two ways. Method 1, separate with statements. The outer with opens the input file. The inner with opens the output file. Both are closed when their respective blocks exit. Method 2, single with statement with multiple managers. You write with open of input as fin, open of output as faut. Same effect, cleaner syntax. Available since Python 3.1. Important, context managers close in LIFO order. Last in, first out. Faut was open last, so it closes first. Font close second. This matches the natural stack order and prevents dependency issues. ContextLib also gives you suppress, a context manager for silencing specific exceptions. Without suppress, you write try except with pass for lines of noise to say I don't care about this error. With suppress, you write with suppress of file not found error, one clean line. If file not found error is raised inside the block, it is silently ignored. Any other exception propagates normally. This is perfect for delete if exists patterns, best effort cache writes, and any place where failure is acceptable and expected. It is not about hiding bugs. It is about being explicit that a specific error is intentionally ignored. Context managers appear everywhere in real Python code. Let's build a timer, one of the most useful utility context managers. We use the context manager decorator. Before yield, record the start time with perf counter. Yield, the user's code runs here. After yield, compute elapsed and print the result. Now we use it with timer of db query. Everything inside is automatically timed. Other real-world uses include threading, lock for thread safety, contextlib that redirects DOUT for capturing output, unitus.mock.patch for testing, SQLalchemy sessions for database transactions. Every time you see a with statement in a library, it is this exact pattern underneath. Our mini project, a safe database transaction manager. This is a real production pattern used in web applications. We use the context manager decorator. We connect to the database, then yield the connection. If the block completes without exception, we commit. If an exception is raised, we roll back. In the finally block, we always close the connection. Notice the three guarantees: commit on success, rollback on error, close always. This prevents partial writes, connection leaks, and data corruption. Now we use it with db transaction of app.db as con. Con is the live connection. We execute our insert. When the block exits, commit or rollback runs automatically. This is exactly how ORMs like SQLalchemy work internally. Your challenge: build a thread-safe lock manager. Step 1. Create a context manager function called locked that takes a lock. Step 2. Acquire the lock before the yield. Step 3. Release the lock in the finally block after the yield. Step 4. Use it with 3 threads, all writing to a shared list. Step 5. Run 1,000 iterations per thread. Verify all 3,000 writes succeeded. No race condition. This is a real concurrency pattern. Without the lock, threads overwrite each other. With your context manager, every write is safe. Paste your complete code in the comments. I check every single one. Let's recap what you learned today. The with statement guarantees automatic setup and teardown. Enter runs on entry and returns the as value. Exit runs on exit. Always, even on exception. You can build class-based managers with enter and exit or use a context manager with a generator function, simpler and more Pythonic. Yield is the boundary between enter and exit logic. contextlib.suppress silences specific exceptions in one line. Nest multiple managers. They close in LIFO order. Real patterns include files, DB transactions, locks, timers, and HTTP sessions. Next episode, testing with PyTest, test functions, fixtures, parameterize, and mocking. Subscribe so you don't miss it. See you tomorrow. Context managers mastered. You can now write leak-free Python that handles errors gracefully. Subscribe for the next episode. Drop your lock manager in the comments. I am Mahaz. See you in episode 20.